let's do this one. So copy and complete the table, pretty straightforward. Instead of, writing 1 over x, you just write these numbers. So this one, technically it was 1 over 1, but that's 1, so they just written it like that. Instead of x here, they wrote a 2, so over here they got a 2. So hopefully you understand that this one's just 1 over, instead of x, you put a 3. This one is just 1 over 4. This one is 1 over 6. So hopefully that was pretty straightforward. Let's draw a graph of y against x. Okay, so y, nope, not as straight as I hope. That's my x. Alright, so let's just plot them basically. My y is 12. My biggest number is 12, so I want to make sure I can get all of those in. So maybe I'll just do approximately 5, 20, 12. Oh, not 12, 15. This approximate is fine. Oh, my bad. This is my x. I really should have looked at this value. My bad. So I should have 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. That's right. Everyone makes mistakes. Let's give these ones a go. So I just need to basically have 0 to 12. Am I going to fit it if I go up by 2? So let's just give it a go. If not, I'll rub it out and do it again. Bit of trial and error with the scales. Alright, let's give it a go. So let's dot points. So I've got it. X is 1, and then y is 12. So I'll go over here. X is 2, y is 6. X is 2, y is approximately here. X is 3, y is 4. X is 3, y is 4. X is 4, y is 3. Over here. X is 6, y is 2. Approximately here. So let me draw that little graph. Something that looks like so. Label it. I don't know the equation, so I might just leave it. And that's it for now. That's all I can do for now. That's done. Show that x and y are inversely proportional. Alright, so inversely proportional, remember some of the notes that we have written. I think the key note was that it has a relationship y equals k over x. If I rearrange that, I get y times x equals this constant, I think we called it, k value. So when we basically times x and y, you should always get this value k. So let's give it a go. Let me get rid of these so we can give it a go. So if I times these two, what do I get? 12. Maybe I'll use a different colour. If I times these two, what do I get? Well, I get a 12. If I times these two, 3 times 4, I get another 12. If I times these two, I get another 12. If I times 6 and 2, I get another 12. So do we see how our value in that case is 12? And we've kind of verified it by using all of those dot points. So that's sufficient enough as long as you can explain that. You can write it in your own words. I've obviously explained it to you. You can just copy it down and, jot it down in your own dot points. Alright, let's do D. Okay, so let me write B here. Then I'll do my next one, which is my question D. Draw the graph of y. So this is my y against 1 over x. So make sure you read your 1 over x values. So let me tidy that up a little bit. So it's going to hopefully look a little bit different. Alright, so my 1 over x value is now 1 half, 1 over 3, 1 over 4, 1 over 6. Now those numbers are smaller than 1, so just be mindful. So I'm going to put 1 here. Let me actually kind of just figure out where they all belong. So they need to be an equal scale, which is hard. I might have to convert them all to a base number of 6. So 6 over 6 for the first one, this one, and I'm just going to write it in order so you kind of follow. This one, if I times bottom by 3, it becomes a 3. Next one over here, it becomes times by 2. Next one, I just realized I can't even make 4 into 6, so I have to change the denominator to 12. So we need to have a common denominator. So first one will be 12 over 12. If I want to get to 12, I've got to times by 6, so it gives 6. Hopefully you're following what I'm doing. It's just simple, manipulating fractions. Next one is 3. Next one is 2. So we just have to make sure we write all of those data points in. So 12 out of 12. So I'll write it as 12 out of 12. Oh am I going to make it? So halfway, so I should never really, I don't really like to start at the end. So I'm going to start over here. 2 over 12. I might have to extend it a bit. 4 over 12. 6 over 12. 8 over 12. So let me extend this a bit. So this is why, hence, using a pencil is much easier because there's a lot of editing to do, which is okay. Okay, now I've kind of got that across, so just have in mind that this order is that order. I just couldn't be bothered writing another table. So hopefully you're following. This is my 1 over x. My y value stays the same, 2, 4, 6, blah, blah, blah. 12, 2, 4, 6, 8, 10, 12. Brilliant. Now let's dot it. So when my x is 1, which is the same as 12 over 12, so over here, my y is 12, so over here. When my x is, remember this one, a half, which is a 6 over 12, my y is 6, so 6 over 12, my y is 6. When my x is 1 over 3, which is 4 over 12, so over here, my x is 4, so over here. When my x is 3 over 12, which is kind of approximately here, my value is 3, so right there. My value is 1 over 6, which is the same as 2 over 12, over here. My value is 2. So here we go. So approximately, let me see if I can use a different color. Looks something like so. So we know that this is a linear graph. Well, it looks linear, so I'm just going to assume it is. So there we go. Now we're just going to show that this relationship is directly proportional. Easiest way to do it is find that, m value. Remember, y equals mx, that constant value. Easiest way to do it is have a look at your variable and find your gradient. Easiest way to do it is rise over run. Choose 2 dot points. I'm just going to maybe go for these ones over here. y2, take y1, x2, take x1. Okay? So it becomes, hopefully you know which ones to label, but if not, just go have a look at the table. y2 is 6, y1 is 12, x2 is all half, x1 is 1. So if I just chuck that in the calculator, I get 12. Okay? So, in order to figure that out also, is I can just quickly have a look at that and rearrange it again to get, m equals y divided by x, because I just got rid of the x from that side. And if I just go 12 divided by 1, I get 12. If I do 6 divided by a half, I actually get a 12 if you use your calculator. If I do 4 divided by 1 over 3, you get 12. If I do 3 divided by 1 over 4, I get 12. 6 divided by 1 over 6, I get 12. So it just confirms that it has a linear or directly proportional relationship. And that's it.